Okay, so from the previous task comparing the algorithm, I managed to get the boosted decision tree still the best. Yeah, so I will save this experiment as number 3. After that, continue with the tune model hyperparameter. Okay, so this tune model hyperparameter is basically we're going to iterate the parameters not only using the single parameter but through the parameter range, and then the machine learning will suggest to us which parameter is the best, yeah, for our BTT. So I don't need all of this, and I'm going to use the boosted decision tree for the tune model hyperparameter. Okay, I can use I just copy this one. Okay, after that I drag the tune model hyperparameter here. Okay, so the boosted will be this training will come to the most left. After that this one, the data come to this. Okay, and then after that so the tune model hyperparameter is basically replacing the train the model, yeah. And then for the score the model, we going to drag the model, the train based model, yeah, come to this, yeah. And then here in the tune model parameter, in the boosted decision tree, you replace with the parameter range. Okay, so by default it will come out with this parameter range. The maximum number of the leaf 2, 8, 32, 1 to 8, yeah. And then 1, 10, 50, and then range builder 0. Sorry, the learning rate, yeah, 0.025, 0.05, 0.1, 0.2, 0.4, and this, yeah. So that's the parameter range that we're going to try. And then here we're going to configure the tune model hyperparameter to use a random sweep, and then random seed, yeah, you can put any seed or just leave it 0, and then the based on the arrival delay. Okay, for the regression I'm going to use the RMSE as the main, yeah. So root mean square error. Okay, so only this you have to change, the rest are using the default. Okay, so if you do this, then you will take quite a long, few hours, yeah, because this one is about a few million row, yeah. So alternatively, if you don't want to wait too long, because I can give you the hints in advance that not much improvement will be obtained from this, yeah. So you can like this, yeah, or before you pass the data to the tune model, you can actually using the partition. So the purpose of the partition and sample is to only use a certain percentage of the data here, yeah. So you can for example use just the 10%, 0.1, yeah, 10% of the data, not all the 70% of the 2.7 million, yeah. So that's the purpose of this, yeah, to reduce the data for training. Okay, but if you have enough time, then no need to add this one, yeah. So this is just for the time sake, yeah. I don't want to wait too much time, yeah? So I just take 10% of the data. Okay, so I save, after that run. So after this we're going to compare, eh? So with the tune model hyperparameter, the result, is it better or not? If it is not better or not much significant, you can use the default setting. But if it is better, then you're going to take the parameter value and then apply to this boosted. Okay, so I saved, and after that run. This will take a while, yeah. I just leave run, and I pause the video. Okay, so for this 10% partition will not take too long, yeah, maybe 10 minutes will finish. So I compare between the original BTT and yep, so you can see here 12.77, 12.8, yeah, okay, 0.88, 0.88. Okay, this one is still better, yeah. So the tune model hyperparameters with the 10% data didn't give you a better result, so you can keep this, yeah. Or if you have a free time, then maybe I can remove this, yeah. Just remove this, and then after that link directly here. Okay, after that save. This will take longer time, but anyway I will leave it running, and then check again after 1 or 2 hours later, and I will give you the result, and you can decide whether you want to use partition or not, yeah. Okay, so let me run this first, and I pause the video, wait for the result to be completed. It will take longer time, definitely, yeah. Okay, so after I leave this run overnight, so I don't know how long this take to finish, yeah, but now the tune model hyperparameters already completed, and we're going to check this one is using the all data, yeah, without the partition, and yeah, as we predict, then it gives us slightly a better result, yeah. So the RMSE down almost 1 minute from 12.7 to 11.6, and then this increase from the 0.8 to make it 0.9, yeah. So this is nice, and we're going to take this, yeah. So this the result from the tune model hyperparameter, we will take this as an improvement. Okay, so this one is the sweep result. Visualize. Okay, yeah, look at the RMSE, which is the best, yeah. Okay, so this is the parameter that we're going to use. The learning rate is 0.37, and then the minimum lift is 26, number of lifts of 690, yeah. Okay, so I take this screenshot, yeah. Okay, we're going to use this as the best parameter. Okay, then yeah, we put this boosted decision tree into this parameter, yeah. Okay, let's have a look. The number of leaves is 90, and then minimum is 26, yeah. So I change this to 90, and then this 26, and then learning rate is 0.7375257. Okay, 375,257, and number of tree is 350. So increasing this means that your training time will take longer time, and then yeah, okay, so that's the best parameter obtained by this tune model hyperparameters. Okay, so I save it. Okay, sorry, I think I have to save as, yeah. Save as number 4, okay. It is I'm going to use this for the later cross validation. Okay, yeah, I stop this video, then I'll continue with cross validation after this in a separate video. Thanks for watching.